cover every lesson that we're going to do this week. We are looking at 7.3 today, and for 7.3, the first thing that we're going to do is a quick little warm-up. So you got these two problems. You're determining, is it arithmetic or geometric, writing the explicit, and then calculating a term. So go ahead and try that out. I'll give you about 4 minutes to do so. That 0 point.
It's going on by 11, so it's a linear one.
All right, so check and see how you did. A couple things for you. So, first problem, geometric. A lot of you had either the fraction or we got that 0.3 0.3. Now, 0.3 is exact. I would accept that. Okay. I will challenge you repeatedly to use a fraction. It's always better. However, 0.3, there's no approximation there. So again, that would be okay. And if you use that, that's fine. I have this answer in red. I'm going to talk about it in a moment. We got the other thing that I want to talk about is how we find that multiplier. And remember, you're just taking 390 or 27 and dividing it by the previous number. And if you do that, it always works. You get that. When I look over here, I'm arithmetic. I got my explicit. Do I have a number in there for n right now? No. If you do, it's wrong. So that 27 is another problem. It's separate. Okay? Don't combine them. So we got this. I go ahead, plug in, I get 321. Are we good on that one? All right, this one. So we talked as an Elge2 team, and we decided that, if you type this in and you try to make it a fraction, it's not a fraction, right? It can't be one. So if you go right here and you get to the thousands place, or take that, okay? And the reason being is because, if I make you write that whole thing out, one calculator versus another calculator, some of them are going to be just slightly different towards the very end because you run out of digits on one and the other one has a few more. And then the other reason being is if you're writing all these digits out, you might forget a 0, you might forget a 1, you might forget one of those digits, and then it's wrong. So we're being a little more concise, we're being less accurate, but a little bit more concise, okay? So if you try to make it a fraction on your calculator and you can't get that, 3 digits is fine after the decimal. Does that make sense? All right, we'll practice that more today as the day goes on. All right, so we've done arithmetic sequences and series. So we found just terms and we found sums. And we've done geometric, we found terms. But now we're going to find the sum of those things. So our first problem has this formula right here. And I'll tell you right now, this isn't hard. The hard thing is, can you type it in that dang calculator of yours? So I'll show you how I write stuff, and then I'm going to show you how I type it in my calculator. Because what I write down is not always what I type in. And if you have a Casio, you're a lucky person. Because they make your life a little bit easier. They got a fraction key, so you can type that in. If you have the scientific ones, then you just got to make sure you're using parentheses correctly. And I'll be writing up there what I would type in, these blue ones or the pink ones, so that works out. So we're going to find the sum of this series right here. And notice, where's g of n? Up here. Where's my last term? There's no g of n. Okay? So if you're looking for a geometric series, the sum of it, you actually don't need to know your last term. You need to know your first term, how many terms you're looking at, and then what your multiplier is. That's it. So we're going to do a couple calculations and see how it works. So the sum of this one, my first term, g of 1 is 3. My multiplier in this case is what? 2. And then how many terms do I got? How many? 8. So I'm going to put an 8 up here. That's going to be different than what I typed in my calculator in terms of how it looks. Then I close that, and then I got 2 minus 1. So let's think about this. 2 minus 1, come on people, it's just 1. Don't type that in your calculator. That's just room for mistakes to happen. What is anything divided by 1? Itself. So I'm actually going to do nothing with that. Okay? This time. I can't do that every time. But I'm going to show you each problem just to get used to it. So how do I type this in? I'm going to type in 3, and then a parenthesis, and then I'm going to go 2. I'm going to have the caret of 8, and then minus 1. Close parenthesis. This one's an easy one because of the one on the bottom. So let's all type that in, get an answer, and then we're going to move on to ones that get a little bit more complicated. What do you got? All right. So this one is equal to 765. We good on that? Okay, so the sum of the first 8 terms of this series add up to 765. Nothing too crazy. But now we start getting into slightly more murky waters. We're actually going to start down here, writing this in sigma notation. And if it's asking for summation notation, I want sigma notation as well. So we're going to be writing this out. So I got sigma right here. I'm going to use i's today. You can use n, whatever you want. We've talked about that. But I'm going to use I, so I'm going to say I equals 1. And if I'm writing sigma, I'm always starting at 1. Then I look up here, and it tells me calculate the sum of the first 12 terms. So that means 12 is going right up top here. And then we need to write an explicit formula for that geometric series right there. So what's my first term? What is it multiplying by? All right, so then that's all we need. So I got 5, and then times 2 to the I minus 1. Now, again, if you use n, just put n up there. So if it's n, it's n. If it's I, it's I. Whatever it is, it's fine. You use one of those two, though. So your homework is pretty much going to give you something like that. It's not going to give you something like what's up here. It's not going to give you those words. But realize this is telling me all those words. It's telling me calculate the sum of my first 12 terms of this series. Okay, let's start doing that. So I'm going to calculate the sum now. My first term shows up in both places. It's 5. And then I'm going to have r, which is 2. And I'm going to raise that to the 12th power. Now remember, I'm writing this how I write the formula, and then I'm going to change it so it looks more like your calculator. So then I got minus 1, and then down here, I still have 2 minus 1. So we're still kind of a nice problem. So what's this look like? It's just going to be 5 times 2 to the 12th. I have a parenthesis there. Minus 1, and that should give me my answer. If I don't put that parenthesis here, it goes 5 times whatever that is, and then it takes the 1 away. We don't want that to happen. We want this 2 to the 12th with minus 1, and then times the 5. So let's get that answer. Type it in. Keep practicing, get used to your calculator. Again, I'm not really doing any division here because this is just 1. If it was a different number, then I have to do something different. And this is actually how many goals Wendell has scored in his hockey career. How many goals you got, Wendell?
Apparently 20,405.
I think they should be putting your name on a banner somewhere. But we're getting there. We're getting there. Questions? All right, now the waters actually get a little bit more murky. So example 2, things are changing. Not a whole lot, but they are changing. So we're going to start with sigma notation again, because I want us to get used to seeing sigma notation, understanding what it means, and then solving that problem. So I purposely slid this away, so you have to tell me what you're thinking it's going to be. So we're still always going to choose the bottom to be 1, because we get that choice when we write this. How many terms am I looking at in total? 9. Thank you. What's my first term? 5,000. And remember, I'm asking my first term because I'm putting my explicit formula here. So I got 5,000 times what? Negative 1/10. And then I'll have I minus 1. All right. This is all I got. I opened the packet up and this is what I got. Now I'm going to solve. So this is telling me find the sum of the first 9 terms given this. So formula looks like this. It's going to look like 5,000. And then I'm going to have negative 1/10 to the 9th power minus 1 all over negative 1/10 minus 1. That doesn't look very nice. How the heck do we type that in your calculator? There's going to be two options. First option is figure out what is the top, hit enter, and then divide by what is on the bottom. And you can do that. That's fine. I'll actually do that on the next problem. The other option is type the whole dang thing in. So, do I know what negative 1/10 is as a decimal? Negative 0.1. That's exact, right?
Yeah.
So I have not rounded. If you have not rounded, I would honestly use the decimal in my calculator because it's easier. So this is how I would write it out. I would write 5,000, and I'm putting a parenthesis here, and then I'm putting a parenthesis there, and I'm going to go negative 0.1 to the 9th power minus 1, and then I close that one. I also have to close the one in front. And that's telling my calculator this is the top of a fraction. Okay? It's keeping it up there. Then I'm going to put divide. And then I got to use another parenthesis here. And I'm going to go negative 0.1 minus 1. Close it. You type that in, you're going to get the right answer. So, try it out. Watch these, because those have to be the negative symbol. They cannot be a subtraction. So type that in, see what you get. If you got the Casios, just make a fraction and type it in like what's on the screen. And this does not become a fraction based off the calculator that I have. So I'm going to go like this, 4, 5, 5. And I'll walk around, and if you're struggling to get that, let me know. I'll help you out. Doing good? Yeah. All right. Any questions at all? Next one. We got a bunch here. We're not going to do them all. So please don't do them all. We are going to change this problem right here. We're going to put a 0 right there. Because you get some on your homework that look like that. And because we can. And it doesn't change a whole lot. So this is telling me to find the sum from my 0 term all the way, no, I'm actually not going to change that. Erase that back. I'll talk about it later. So we're going to find the sum of how many terms here? 17. What's up? Actually, I beat Miss Wallace. Rock, paper, scissors.
As I say, if you can't make up your mind here, how are you going to make up your mind for rock, paper, scissors?
It did not feel fair. Not gonna lie. I had to explain. She's like, remind me of the game. I was like, oh my gosh, this is not okay. But yeah.
Alright.
We have our own little same rock, paper, scissors you guys had in homework. Our math department is doing it. Okay. Alright. So looking at this, we got how many terms again? Just want to make sure I'm on the right spot. 17. Okay. So let's start filling this out. What's my first term? 1,500. So I'm going to start writing this out. So I got 1,500. And then I got 2/3, which I'm going to change how I write it in a minute here. So I'm going to put 17 up there. Then minus 1. all divided by 2/3 minus 1. So how do I type that in my calculator? If you have the Casios again, fraction key, type it in. You got the scientific ones, you're going to type it in like this. Again, you could type just the top in, hit enter, and then do the bottom. Or you can type the whole thing in. So I'm going to type it in like this. 1500. Notice I'm color coding my parentheses so you can see where they're at. I actually have to add another one. Because 2/3, what is 2/3 as a decimal? 0.6 repeating. So then some people are like, well, it's 0.6667. So then what do? You can't. We can't approximate it. So we got to type it in. So I'm going to go 2, don't use your fraction key, divided by 3. I close that parenthesis. And then I go ahead and I put raised to the 17th power minus 1. And I'm closing both of these. You could hit enter if you wanted right there. And then you have to go divide by 2 parentheses here. 2 divided by 3, close 1, and then minus 1. Type that sucker in. So again, the formula is not that bad. Can you use the formula? That's what becomes kind of a pain. Wendell, someone's gonna mug you.
So they got no.
And so this also does not change to a fraction. And I got that. If you did get that, I'm going to walk around, please ask, and I'll help you get that. Yes. Yes. You see it. Well, alright. Just try that again.
Why do they go to the thousands?
To be more accurate than what we normally are. And stress that we're trying to be extremely accurate.
How do I send it?
All right.
So every time there's a fraction, you just put 2 parentheses.
Yep. Just whenever there's a fraction, you have to put parentheses around it. Okay.
Oh, wait.
Yes.
No,
Now
I
this one, I truly don't because my calculator will follow order of operations. However, I just do it so that it's always clear cut. Fraction, parentheses.
so I
Then you don't got to worry about it later on somewhere else.
just put a parenthesis.
Okay. Moving on. We're going all the way to the bottom here. And on this one, we're going to make that 0. The very bottom one. So leave that middle open because we're going to use the middle for something else. So we start off. I got 0 right here. Let's make sure we know what our, and folks, when we have g of 1 in the formula, that is representing your first term. This is telling me my first term is 0. So whatever this is when I plug it in is going to be the first term in my formula. So don't take g of 1 as like, it has to be that first term of having a g of 1. It could be the g of 0 or whatever it is. So I start with 0 and I plug it in. What's 5 to the 0? 1. Okay, so watch out for that. 5 to the 0 is 1. So 2 times 1, I get 2. So my g of 1, I'll put little quotes here, equals 2. So let's write this out. So I get 2, and then parentheses here. Now my multiplier is 5. How many terms do I have? I have 8. Because now I'm starting at 0. So I go 0, 1, 2, 3, 4, 5, 6, 7, 8. So I have to add 1. If I don't start at 1, I have to add 1 for the 0. If I started at -1, I would add 2. Okay? And you can play around with that. You can actually write them out and start figuring it out. That's what I really wanted to show you. So I got 8 right here. And then -1. And then down here, what number is going to be down here? Don't give me the 2 numbers. Give me the 1 number. What's my multiplier -1? 4. So I am just right here. I'm really doing 5 minus 1. So when I type this in, I'm going to type in 2, and then 5 to the 8th, minus 1, close that parenthesis, and then divide by 4. And that will give me an answer. So let's all type it in, make sure you can get it. Wait, you got this. Yeah, why not? Oh, I thought you said I like that one. Okay, my bad. Nope, we're good. So, I like that. That is what we get right there. Now we're going to apply it. So that middle space we left open. Anyone have a dream job? A mathematician. Straight up mathematician, nothing else. Alright, let's see what a first year mathematician makes it a mathematician job.
That would be so cool. You get boring eventually.
Alright, so it says entry level is 56 to 97. We're going to go with 56. We're going to go with the bottom.
56,000.
56,000. It says 56 to 97. We'll go with the bottom though. Alright. Oh, come on. No.
So that is a math.
Alright. So, first term, $56,000. Griff, now we're just going with you though. So, are you going to do a good job at your first place of employment?
If they pay me $56,000, depends on like the long term on that. Because if I'm not going to be making more as I work there, like I'm screwed up.
Okay, so let's say that you're be happy. You're going to try pretty hard.
Oh, I'll try. Yeah.
Okay, so let's say that they decide that they see Griffin after a year, and they're like, "Man, your hard work paid off, man. We're going to give you a 9% raise." Is that pretty good?
Yeah.
All right, 9% raise. How do I write that as a multiplier? Decimal is actually what you do with percent raise. What? 0.09? 1.09. Yeah. So if our raise is 9%, that means we're getting 1.09 as our multiplier. So that's what R is going to be. Now, a couple things you got to realize about a raise. First of all, the main thing that affects your raise is going to be inflation. If inflation is 9% that year, it's 9% of your raise. No, because it means you're not actually getting a raise. You're getting more money, but your buying power has stayed the exact same. You haven't gotten anything. Now, most of the time, inflation is like 2 to 4, somewhere in there, maybe a little bit more. Just depends on the year. So let's say inflation that year is like 2%. So, Griff, great raise. Okay? So, let's calculate. How long do you think you're going to work? You're going to work till you're
So like
50, 90,
Give me 70, dude.
70?
I'm working.
I'm going to 101.
I'll tell you right now, I will not be here when I'm 70
I
years old.
will though. I'm
So,
pursuing that.
starts when he's 20 years old, walks out the door, walks into his little cubicle that he starts in, and 50 years later, because he's now 70. Good for you. He walks out the door with his last paycheck in hand. We're gonna figure out what is that paycheck. So we're gonna use our explicit formula. So I'm gonna look for G of, we'll just say 50. And so I got 56,000 times 1.08, and I'm gonna raise that up to 50 minus 1. So I'm looking for that 50th term. What? Oh, I do. Sorry. The last class we did 0.8.
Trying to cut my raise now.
I am. Gotta watch that corporation, right?
Little boy Nichols.
Alright, you calculate. Give me a number. We're gonna see if we break the calculator here. It's gonna be big enough. Oh, you're doing pretty good.
Am I affluent?
Mine's kind of dumb, so hopefully it doesn't.
What do I have here? Point what?
Do you want to go to the thousand?
87. What are we talking about here? Money.
Oh yeah.
I will never give you directions on how to round money, ever. And I will always expect you to round to the hundredths. So, we get 0.87. What do you think? Was it worth working hard your first couple years?
Oh,
Oh yeah. He walks out of there making $3.8 million. I would say that's not too shabby. Now, are you going to get a 9% raise every year? Maybe not. But, you know, if you did, that's where you're sitting. It's pretty sweet. Although, granted, you're walking out of there with a cane, but, you know, each.
They took the prime away from me, but
All right.
It's gonna be you.
That is not going to be me.
why? You're not gonna. You get 9% raise.
No.
You would-
9% is kind of crazy, actually.
I'm happy about
I'm
that.
walking out of here when I'm 55. That's the goal. All right.
This can go live in this beachfront condo.
Beachfront condo.
Don't have one of those, but maybe one day I will.
I think
So
more of a hunting cabin than-
let's talk about this then. Let's find out how much money did Griff make over those 50 years. So the sum now. So now we're calculating. We're going to take 56,000, and I'm going to have 1.08 to the 50th.
9.
Yeah, thank you.
Yeah, start trying to cut me out.
All right, minus 1, and then all divided by, I'm going to just put 0.08 right there because I'm doing the 1.08 minus 1, and I'm just going to leave that there. Makes our calculation a little bit easier. So what do we get? I'm not even going to ask because I don't want to, I'll just write it down and see if we agree.
Wait, what is it? Is it supposed to be 0.08?
Yeah, because no, it's 0.09. Oh my gosh. Cheating you out of everything I can. Although this would actually help you out. So 0.09.
Yeah. My rate can get it.
You could say that.
I made like $45 million.
That's unreal.
Yeah,
That's not even close to a real.
who's the highest paid mathematician?
Stat right there, dude.
The highest paid mathematician? I don't know, but they can make a lot of money.
You know, there's like a general surgeon for like the best surgeon. There should be like a general mathematician in the United States of America.
So actually, I when I was in Rylander, there's this guy. He had a PhD in mathematics and in physics and computer science. Actually, no, he only had a master's in computer science. He clarified that. So he was a student that went through Rylander, and he just did a virtual meeting with students to like kind of like show them what they could do with math and like talk about things like that. But so he was probably the most interesting presentation I've ever seen because so he worked for the DoD, so the Department of Defense. And so he did not pay for a single one of his PhDs or his masters. He didn't pay for any of it. And so when he gave us a presentation, he goes, yeah, so just so you're aware, like if it looks like I just stopped talking or saying something, it's because there's someone behind me that has to like moderate what I'm saying. Like I'm not allowed to just give this presentation on my own. And he goes, and the slideshow might not make sense because I had to submit it before and they redacted some stuff. Like not like really anything, but they might have looked at a picture and said, that's revealing too much of what's going on. He's like, and I can kind of talk about what I'm doing, but I can't really talk about what I'm doing. So I'll just talk about some stuff. But so this guy was crazy smart. But so he showed us like a bunch of nuclear like test sites and like different things like that. And it was all virtual. But that was a really cool presentation. I don't know what he makes, but
How much did he get paid to get brought in compared to like the other people that just show you PowerPoints?
he didn't get paid anything. He volunteered his time. He only came to it was a pre-calc and a calc class that we just had them sit down and they got to ask him questions and things like that. So that was pretty cool. He only did it because he was really good friends with one of the teachers up there. But
Are you good friends with him?
unfortunately not. I thought about reaching out. I was like, no, he probably wouldn't even get the email.
Bring it in,
So,
man. Bring it in.
Um,
I'll talk
but-
to him.
that was pretty cool. So here we go. So Griff, if he adds all of his salaries up, he's making $45 million, almost 46, and then
That's good stuff.
that is a lot of money. So you can kind of think is a 9% raise good every year. It would be amazing. But what I'll tell you is this, if you look at this amount right here, $56,000, and you go to this amount right here, that's kind of what happens if you put money in like the stock market. Like if you invest money, not necessarily just in stocks, like bonds and other things too, just saying the stock market in general, 50 years is a long time, but your money grows a lot. And 1.09 would be pretty good. Like 1.07 is more approximately accurate to what might happen. But 1.09 is not unheard of. So I just want you to realize that, if you want to make more money than what you're making, let your money work for you. Like if you're going to save it, don't save it necessarily in a bank where your interest rate that you earn is like 1% or something like that. Not even that, like 0.25%. Throw it in the market. The only thing is you got to be willing to accept the highs, which is easy, but also the lows. And to be more honest with you, when you're investing money, you want the market to be terrible. You want it to be really low. You want it to be doing really bad because that means all the stocks are cheap and you're getting the money. And then when the market does good, your money is growing the most. But there's the other secret, which is nobody ever times the market right. So if you just put money in over an average and let it grow, it'll be fine. You gotta look at like 10 years though, 15 years. And the other thing I'll say is, some people are like, I put this money in and then right here, it dipped down, but I need that money now. Like what the heck? I just lost like $10,000. You lost $10,000, but you might have started with 5 and been at 5,000 and been at like 22,000. So yeah, you lost $10,000, but you still made 7 and you didn't do anything to work for it. So just something for you to think about. I'd highly encourage you to look at investing in your future at some point.
How much are bonds actually worth? Because like bonds are like the most steady kind, aren't they?
They can.
Like
They're
government bonds.
there's a bunch of different bonds, and then you like purchase them, and then they pay you back at certain rates. But all the rates are determined based off when you bought it and which bonds you're buying. So I don't have like a perfect answer of which one. A lot of people, there's a lot of talk about government bonds right now, and sometimes they're good, but it's when you buy it. So if you buy it and the return rate is 4.5%, that's what you get back. But tomorrow it could jump up to 6, and then you're kind of like, oh shoot, I lost some money because I could have got 6% instead of 4 or whatever. But then they could also drop down and only pay back 2. But then you're locked in. So you're just locked in. So if you find something you're comfortable with, just buy it and then just let it give you money back. So.
Because how much Bitcoin you got?
Do any
None.
of these?
So I'm not a Bitcoiner. That is our lesson. So you can start on the homework